Hey everyone, welcome back. Let's write some more Leetcode today. Today we are solving count of substrings containing every vowel and k consonants too. So the problem states that we are given a string word and a non-negative integer k, and we want to return the total number of substrings of word that contain every vowel a, e, I, o, u at least once and exactly k consonants. So if we look at these examples, this one has the output of 0 because none of the substrings have a, e, I, o, u. This one has an output of 1 because it has a, e, I, o, u and 0 consonants, which is what we wanted, and we have one substring of that. And this one, we have 3 substrings, which is I, e, a, o, u, q, and q, I, e, a, o, u, q, and I, e, a, o, u, q. So the output would be 3. So now that we have seen some examples, let's get to how we can solve this problem. So one way that we can solve this problem is we can use the sliding window approach. And what we will do is we will have a hash map that makes sure it has all 5 vowels in the hash map, and we will have a variable that keeps track of the number of consonants. They are not written here, but you will see it when we get to the coding section, but I will just show you the pointer visualization for this example. And every time we find a valid substring, we want to add the length of the string minus the right pointer to the result. And for us, instead of finding the valid substring with k number of consonants, we're going to look for k or more consonants. So we can have unlimited number of consonants, even though the problem states that we need exactly k consonants. So what we will do is we will first find the result of k or more consonants, and then we will subtract by the result of k plus 1 or more consonants. And then we will know the result for exactly k consonants by subtracting this to this. So now let's go over this example. And for the sake of time, instead of sliding through every pointer, I will just go over the windows where we have a substring that qualifies. So first we will calculate the result of k, and we find the first valid substring when the right pointer is 5. Remember, we want to add the length, the string minus the right pointer. So 14 minus 5 would be 9, so we add 9 to result. The right pointer is now 7, so we add 7 to result. Now the right pointer is 8, so we add 6 to result. Now the right pointer is 9, so we add 5 to result. Now the right pointer is 10, so we add 4 to result. Now the right pointer is 11, so we add 3 to result. Now the right pointer is still 11, so we add 3 again. And the last instance, the right pointer is 12, so we add 2 to result. Now we're going to calculate result of k plus 1, but I think you guys get the hang of it by now, so I'm going to play the algorithm without speaking. And now we will subtract the result of k to the result of k plus 1. So 39 minus 36 would be 3. So the result would be 3. And the time complexity would be O of n, where n is the number of letters in the string, because that's the number of strings we will potentially iterate. And the space complexity would be O of 1, because we are not using any extra space. So now let's get to the coding part. So first, we will write the result function. So we'll call the variable k. And for vowels, it will be the default dig of int. And to keep track of the number of consonants, we will use a variable started at 0. So the result starts at 0, and the left pointer will start at 0 as well. Now we will shift the right pointer. So for right in range length of word, because we need to check every right pointer. So if the right pointer has a vowel, then we need to add it to vowels. Otherwise, it's a consonant, so we will just increment consonant by 1. Else consonants plus 1. And now we need to check if it is a valid substring. So when the length of vowels is equal to 5, greater than or equal to 5. But actually, it will only be 5 at most, since it's a hash map. But for some reason, I wrote greater than or equal to 5. And yeah, we want to add it to result if it qualifies. And if the left string is a vowel, then we need to subtract it, because now we are shifting the left pointer. Otherwise, it's a consonant, so we subtract consonants. And If we run out of a certain vowel, then we need to delete that key from the hash map. So the word dot left, if it's equal to 0, then we gotta delete the key. And we cannot forget to shift the left pointer. And we can return the result for the function at the very end. So return result. And now we just want to return the result of k minus the result of k plus 1. Alright, let's see if it works. Okay, perfect. Hope this was helpful. Thank you all for watching. If you have any other questions or comments, feel free to leave it down in the comment section. And I hope to see you all again soon.